Everyone to free session 3. Today we're going to be talking a little bit about schematics. What are they? What are data sheets? As well as common electrical equipment that engineers use and microcontrollers.
Okay, so we're going to be starting off with schematics today. So what are schematics? Schematics are a simpler way to draw out a circuit. And the way we do this by using multiple different symbols to represent different components. So over here on the left side, we have logic gates. This is the kind of stuff that you're going to see in classes like 201. So stuff like AND gates, OR gates, exclusive OR gates, NOT gates, NAND, NOR, and exclusive NOR. So you're going to see schematics like that when you're working with 201. And then stuff that you'll see in like 211, 330 is going to be stuff like resistors, variable resistors, capacitors, inductors, voltage sources, and batteries. But within those, you can kind of draw them out differently. So we can see resistors, you can either have your kind of like saw-looking component there, or you just have like a little box. And then similarly for voltage sources, we see one that just has a plus and minus. That will signify a DC source, but if we have kind of a what looks like a sine wave, it would be an AC source. And yeah, so that's it for the first part. And to continue on schematics, some of the other stuff that we'll be seeing is VCC and ground, which is basically just your power and ground. And they're both tied directly to common power source and a common ground. And then we also have stuff for motors. Motors can be signified as an M in a circle with positive and negative leads. And then we have LEDs, which are arrows pointing away. So there we see is a blue LED, but you have to keep in mind that an LED is essentially just a diode. But what really differs that from a regular diode is the two little arrows that are pointing away. And then on the right of that, we also have a photodiode, and the difference in that one is that we have two arrows pointing towards the diode. And on the top, we have three different symbols for power. So one is just VCC, other one is 5 volts, and then we just have a V plus. And then we also have different symbols for ground. One is just a straight horizontal line, another one is a triangle, and then the other one is 3 horizontal lines stacked on top of one another. So to continue with schematics, so when reading schematics, components are connected by lines, which signify just wires or just connections in between those components. Lines may cross over when you see this. This means that there are two different lines, but in order to signify an intersection, we use a dot. And then we have net names. These are helpful to declare the schematics. Names usually specifies the purpose of the signals. And then we also have function blocks. They're usually broken up into function blocks and then help also make the schematic easier to read. Next up, we're going to see data sheets. Data sheets you're going to see also in 201. And they're just going to help you really understand what's in the little IC chips when you're working with them. So, but what are data sheets? Data sheets are documents that summarize the performance and characteristics of a certain product. They're useful for learning properties and innovations of certain components. And how do you find these data sheets? So the simplest way is to just go up on Google and search up the model number and the data sheet. So for example, here we have a quad 2 input AND gate, and the model number for this one would be D7408. So you would just go to Google, put DM7408 data sheet, and you're going to find a lot of listings. Sometimes you won't find anything, but that's really a rare case. But for something like this, you'll definitely find it. But you just have to make sure that your model number is exactly the one that you have on your IC chip. And so on the left side, we can see important stuff about the product, such as our VCC, our high-level input voltage, low-level input voltage, high-level output current, low-level output current, free air operating temperatures. So we're going to see stuff like the minimum, the maximum, the units, and its normal. And then on the right side of the data sheet, we can see, for example, this is an IC chip, like I said, for a quad 2 input AND gate. So we just have 4 AND gates there with 2 inputs each. And it's not too clear in this schematic here, but they also tell you like the orientation. Normally when you have an IC chip, you go from, let's see if I can annotate this. Is my arrow visible?
No,
No? Oh, man.
it should. Let's see, annotate. Should allow annotations. Here. I
Okay.
gave you mouse control. Does that work?
All right, there's an arrow, just a red arrow pointing there.
Yeah.
So where that red arrow is pointing, that's pointing to pin 1. So you would start from pin 1 of your IC chip and then go down 1, 2, 3, 4, 5, 6, 7. There's 7 pins on this side for this chip, meaning there's 14 pins in total. And then after that, you wouldn't necessarily start up here. You would start at the bottom pin down here. So this would be 8. And then going from right to left would be 8, 9, 10, 11, 12, 13, 14. So it's important to look at your data sheets when you're working with IC chips in order to make sure that you're making the right inputs. And normally right here we have a VCC, which is for our power, and our ground for our chip. If you don't make those connections, what you'll find is that your chip just doesn't have any power and it's not going to work the way you want it to. So we can go on the next one. All right. So now we're gonna talk about more common electrical equipment that we use. On the top right there, we have a digital multimeter, which is gonna be your best friend really throughout your whole EE career. I would say just invest in one and some alligator clips or just different probes, because you're gonna need it for. I say it's very helpful, and sometimes you just don't have them around when you need them. But what they're used for is to measure voltage, resistance, current, and etc. I can see that we have a little tutorial, but I guess we'll go over that later. And then you also work with an oscilloscope. So oscilloscopes are used to display and analyze different waveforms. So even when you're working with DC or AC, you're going to be using oscilloscopes. You're going to definitely see that in 211 labs. If we ever go back in person, 211 labs or just 330 labs. That's when I've used oscilloscopes at least. We're also going to use stuff as function generators and use to generate different waveforms. So this can be a sine wave, sawtooth wave, rise, just the ramp function, stuff like that. And then lastly, we use power supplies, and these just provide power for electronics when testing. So a function generator basically works as an AC signal, while our power supply is just a DC signal. And continuing here, we see that function generators are used to generate waveforms, as we said previously, and so power supplies are to provide power for electronics when testing. So on the left side here, we see that that is a signal generator, and if it's visible, where would they be? These options up here, let me see. For example, this one up here is a sine wave. This right here is a square wave. I believe this is a ramp, if I'm not mistaken, and this is just a pulse. So you have different waveforms being applied into your circuit, and you're going to see there's going to be different applications for each. And then what you have here is just a dial, some numbers, and this is just to change different values of your waveform, such as amplitude, frequency, if you're shifting your signal, whether it be on the y-axis, which would result in your amplitude or voltage, or your x-axis, which would signify time. And then on the right side here, this is just a regular power supply. So what you're going to see here is just voltage and current. So you display you can change either how much voltage you want to apply to your circuit, or stuff like how much current you want to apply to your circuit. And then the stuff down here is going to be where you're going to be connecting your probes in order to supply the voltage and the current to your circuits. Additionally, here, these two little things right here are going to be how you're applying your voltage or current, or your signal in this case, to your circuit.
Okay, so some more common electrical equipment continued. We have right here, it says Klein tools on it with the yellow handles are wire strippers. Actually, sorry, these are crimpers. And what you can do is basically use these when you're to shorten your wires or little nodes on your resistors to make your kind of breadboard look a little bit more succinct instead of having looser connections into the little holes on the breadboard. And then this one under it where it says vice grip is the wire strippers. Before you go ahead and crimp anything, you need to strip the coating, the rubber insulation off the wire, and then you expose the little copper wires inside the insulation. So that's what the wire strippers are used for. And then over here, I have a little picture of the heat shrink, which when you're going to strip the wires and crimp them, crimp connections together, you want to go ahead and put this over the where you just made your connection between two wires, because it's going to go ahead and protect it. It just adds another layer of insulation to your connection. Make sure there's nothing that could touch the wires and possibly short circuit your components. So that's all for those. Okay, next we have proto boards. Proto boards you can use to solder your own connections. Each hole is electronically isolated. This is kind of a more professional way of building your circuit than a breadboard. So you can see this guy is sitting at a soldering station, and he is soldering each individual connection, which would translate to the connections inside your breadboard. This is a way to put a lot more connections on a smaller board, as well as making it a little bit more precise and easier to see. It's just a better all-around design. So yeah, soldering, you use soldering and soldering iron to solder the components together. This would be an alternative to crimping the two components together, and it offers a better connection for the current to pass through. It's going to last longer. And I have a link right here to a soldering tutorial that I'll go ahead and post later along with the video. Let's see. So next we have microcontrollers. Now microcontrollers is a small computer on a single IC or integrated component. It's used to control an embedded system. One example of a microcontroller, or you can see in this picture, is an Arduino. It's based on C and C++ code, and it comes in different sizes. As you can see in the picture, we have the Arduino Uno on the left, and which one is this? I can't really read it. Okay, well, this one's Arduino Mega, and then on the very most right, you have the Nano. Another form of a microcontroller is not really a microcontroller, but it's a Raspberry Pi. It's a lot more versatile, and you can code in any language. But as far as I know, we don't use it that much in the electrical engineering department, and we use Arduino mainly to teach about how microcontrollers are how they work and how to use them. So microcontrollers continued. Like I said, Arduino is a program based off C and C++. It has all the same conventions for variables, and you end lines with semicolons, just like in C or C++. And you can actually call code from, say, C++, call functions from MATLAB as well in Arduino. So it's set up to run in conjunction with those two other types of programs. I believe you can also call program functions from Python. So basically the setup, the code is run once, and the loop code is run continuously. You have to declare all the pin input and outputs for the Arduino board that you want to control. For the Arduino Uno, the max output per pin is 40 milliamps, which is very important. You don't want to source more than that. It'll end up basically short-circuiting that pin, and you won't be able to use it anymore on that board. And 5-volt logic signals per pin, and you do not want to connect more than 2 sources of power to your Arduino board. So here, like I was talking about previously, the setup code is the section of the code where you declare your variables your pin setups, your input and outputs. And this code only gets ran once. As you can see here, we have pin mode. I defined it as an LED, and then you have also defining it as an output, which tells the board that it's going to be drawing current from that pin to source some type of component. And then in void setup, you always have to have serial.begin, and then 9600 is the starting serial monitor. It basically tells the code, or tells the monitor how fast to process the code. And then down here we have void loop. Let me get this out of the way. And this is where you put your main code. This code is going to run repeatedly, like a loop function in C++ or C code. And as you can see here, the code runs until the time turns off. So we have in line 14, just for example, we have digital write LED high. So this is telling the monitor that the LED is going to be true in the high condition, and then serial print LED will turn on if that is true. And then we have a delay of 1000, which waits 1000 milliseconds, which equal to 1 second. Then we also digital write LED low, and then serial print LED will turn off. So what this code does is it basically just turns an LED on and off as if you were to have a switch, an analog switch, but in this case we're using the code to do it digitally. And something very important in the setup when you're connecting Arduino is you want to make sure you have the correct board connected. This goes for Arduino as well as if you're connecting later on down the road a different board like a ST utility link board. You always want to make sure that the processor is talking to the right board, and then the port is always communication 1. And then that's basically it for this slide. Oh, that's actually the end. Okay. Well, that's basically it. I thought there was one more slide for some reason. That's basically it for the presentation tonight. If you have any questions,
yeah, just feel free to just put them in the Discord chat, and we'll get back to you.
Yeah, that's all. Thank you.